I hope we're live. Just let me check if we're live actually. Um, are we even live? Let me see. Just give me 1 second. Okay, yeah, we are live. Cool. So let's start. So so today's agenda will be, let me today's agenda we will be doing get adder info, and um, we'll do get adder info and also advanced IO TCP server client implementation, right? So so yeah, I opened my editor right now. So let's start. I'll share my screen. Okay, cool. So let's start. So this is get adder info. Get adder info is a function used for getting the address info um, about which is related to a socket basically. If you go to the man page of get adder info, so socket address structure to host and service name. So socket address structure to host and service name. So get adder info is in correlation to free adder info. So host name, serve name, which is the service name. So get adder info function is used to get a list of IP addresses and port numbers for host name, and service serve name. It is a replacement for and provides more flexibility than the get host by name and get served by name functions. So it's better than get host by name and get served by name. The host name and server name arguments are either pointed to null terminated strings or or the null pointer. So either pointers to null terminated strings or the null pointer. An acceptable value for hostname is either a valid hostname or a numeric host address string consisting of a dotted decimal IPv4 and an IPv6 address. An acceptable value for host name basically. And yeah, is either a valid hostname or a numeric host address starting string consisting of dotted decimal IPv4 address or IPv6 address. The server name is either a decimal port number or a service name listed in services file. At least one of host name and server name must be non-null. So hence is an optional pointer to a struct adder info as defined by netdb.h. So it's an optional pointer to a struct adder info. Struct adder info, the contents of struct adder info is int AF flags, AF family, the protocol family for socket, AI sock type, socket type, protocol for socket, sock length AI adder length, so length of socket address, struct sock adder pointer of type struct sock adder, which stores the address of this pointer of this type, and its name is AI address, so socket address for socket, and the canonical name. So this is what we are looking for. So when we are giving a name, it should when we're giving a host name, right? So when we are giving a host name right here, we are and this is guided by the hints struct. We want to store our result in struct add info pointer result. So, and this is the pointer to the next in the list because it results in a linked list. So that's cool. Family, sock type, protocol, flags, and stuff like that. So flags, I think as of now we don't need it. If flags is 0, get item gives the default behavior this moment and stuff like that. All of these. Um, let's just read what is there in this um, man page because there's a lot of stuff. So there's an example also. Damn. Oh, you don't need to. Yeah. Okay, that's cool. So then there's an example also uh to to do it. That's cool. I don't know if this example is in all of the systems, but yeah, I'm using a Mac. So Mac has this, so I don't know, I'm not sure. But so this is the example. So firstly, he um, defines struct add info hints result pointed to 0, and is doing memset is nulling out the. I mean, he's zeroing out the hints structure, and then we are defining hints.ai family is equal to pf unspec, which is that we are unspecified and we are looking for anything, and hints.ai sock type is sock stream, and okay, so there's a lot of stuff here, but we will anyway see our code. But as of now, let's just read what is given here. What is this flags fi- field to which the hints parameter point shall be set to 0 or be the bitwise inclusive or of one or more of the values AI adder config AI all AI canon name, all the stuff. The AI adder bit is set. IPv4 address shall be returned only if an IPv4 address is configured on the local system, and IPv6 address will be returned only if an IPv6 is configured on the local system. Nice. So AI all is the bits is set with AI v4 mapped bit, then get adder info shall return all matching IPv6 and IPv4 addresses. The AI all bit without the AI v4 mapped bit is ignored. AI canon name is if the AI canon name is bit is set. A successful call to get adder info will return a null terminal string containing the canonical name of the specified hostname in the AI canon name element or the first adder info structure returned. Um, Numeric host. So basically, all these canon names will return null terminal string containing the canonical name of the specified hostname in the AI canon name element of the first adder info structure return. AI numeric host. If the AI numeric host bit is set, it indicates that hostname should be treated as numeric string. Okay. Defining an IPv4 or IPv6 address and no name resolution should be attempted. Nice. Numeric serve. Then a non-nil surname string supplied shall be a numeric port string, otherwise any AI no name error shall be returned. This bit shall prevent any type of name resolution service, for example, an AS plus from being invoked. AI passive is set. It indicates that the return socket address structure is indented for use in call to bind to. So if it is set, it indicates that the return socket address structure is intended for use in a call to bind to. Okay, well, okay, so bind is actually for passive. In this case, if the hostname argument is the null pointer, then the IP address um, portion of the socket address structure will be set to in addr any for an IPv4 address or in6 addr any init for an IPv6. If the AI password bit is not set, the return socket address structure will be ready for use in a call to connect to for a connection oriented protocol to connect to send to send message of connection less protocol is chosen. Okay, so the IP address portion of the socket address structure will be set to the loopback address if hostname is the null pointer and AI passive is not set. So the IP address portion of the socket address structure will be set to the loopback address if hostname is the null pointer and AI passive is not set. AI v4 mapped AI default is defined as this. Okay, yeah, unusable. If AI flag is 0, um, gives the AI default behavior, which is AI v4 mapped CFG. V4 mapped is basically specified along with the AI family of PF INET6. Get address shall return the IPv4 mapped IPv6 address on finding no matching IPv6 address shall be ignored unless equals PF INET6. So it shall return IPv4 mapped IPv6 address on finding no matching IPv6. Nice. Okay, cool. And config is basically whatever your local host is config to, it will return basically. Nice. That's the default. So to override the default, we pass any non-zero value for AI flags by setting any desired flag values or setting AI unusable if no other flags are desired. Ah, that occurs when AI flag 0 pass AI unusable instead of 0. This suppresses the implicit setting of AI v4 mapped CFG and AI addr config, thereby causing your unusable address to be included in the results. I have one doubt though. Why is if AI bit is set, then why is it intended to call to bind? So let's see. So why? Let's see why is that. Is a part of the get address info function which is used to obtain address information for creating sockets in neural network programming. Okay. The purpose of bind to are meant to be used for binding us rather than connecting to one. Is used to associate socket with a specific local address and port. For a server, this means you'll use bind or specify to specify which address and port the server should listen for incoming clients. For how AI passive change the behavior of get addr info. When you call get addr info, it returns a linked list of struct addr info objects that contain different address information such as IP address and port names. If the AI passive flag is not set, the address will not be returned will be intended for a client, that is it is the address you would use in connect to a server. Address return is if you use in bind. It allows the socket to bind to an address support that can accept incoming content rather than a specific client side address. So if AI passive is not set, the address return will be intended for a client, that is the address you would use in connect to a server. If so, if it is not set, and but if it is set, it is intended for use in bind. It allows the socket to bind to an address and port that can accept incoming connections rather than specific client side address. So is created with AF. It will set the IP address field in the return to in addr any. Oh damn, that's nice. for okay. Is a special address meaning bind to all available network interfaces. Similarly, serves the same purpose for IPv6. Nice, nice, nice. Got it. This behavior allows the server to accept connections from any network rather than being tied to a specific one. Is specific address you pass to. This address would typically be used by the client to connect to a server, not for binding a server socket. So it's always status, right? Get add info, example, HTTP, and hence and result set you're doing at a family. It's pretty neat with service side. Nice. This now contains an address for binding such as in add any and does not contains the address for example on port HTTP. Nice. Contains the address for example .com on port HTTP example 80. So in this case, you would return the return address to connect to a server using connect, not to bind a socket. Interesting. Nice. I mean, I got it. Very cool. So let's just read this. If AI flag is 0, get add info. AI default, that's cool. All elements of outer infrastructure passed via hence must be 0 or the null pointer. Um, nice. What all other elements of the outer infrastructure passed via hence must be 0 or the null pointer. Okay, that's cool. If hence is the null pointer, behaves as if the caller provided a struct add info with AF family set to PF unspef. And okay, so you're talking about if hint is only the if hint entirely is a null pointer, then get add info behaves as if the caller provided a struct add info with AF family set to PF unspec, and all of them is set to 0 or null, which includes treating the AF flags field as the effectively 0, giving the automatic default AI default behavior. So PF unspec. What is PF unspec? Must be there. It's not there. Oh, it's not here, but it's cool. After successful call to get add info, result is a pointer. What is PF unspec? Let me just read it somewhere. I've read it somewhere. What is PF? Damn it. Unspec. Protocol family unspecified. Oh yeah. So and is used as placeholder value in networking APIs like socket, get router info, and others. So you same actually PF unspec. Nice. You want all of the IPv4 or IPv6, right? Nice. Nice. So B. So yeah. Nice. Okay. After a successful call to get out info, result is a pointer to a linked list of one or more adder info structures. So it's a linked list uh, of one or more adder info structures. Nice. So, and the list can be traversed by following the A and X pointer in each adder info structure until a null pointer is encountered. Three members, a family, a sock type, a protocol, and each return a request suitable for a call to socket. Um, okay. Okay, cool. That's okay. That's cool. So all of these fields, AF family, sock type, protocol, in each of these return adder infrastructures are suitable for a call to socket. For each adder infrastructure in the list, the AI adder member points to a filled in socket data structure of length AI adder length. So for each adder infrastructure in the list, the AI adder member points to the filled in socket address structure of length. Okay, of length AI adder length. Okay, nice. So it is a filled in socket address structure of adder length of type adder len, yeah. Well, filled in sock address structure. Nice. Nice, got it. This implemented get out of allows numeric IPv6 notation, address notation with scope identifier as documented in section 11 of RFC 4007, but by appending the percent character and scope identifier to addresses, one can fill this since 6 scope ID file field for address. This would make management of scope address easier and allows cut and paste input of scope addresses. Um, with scope identifier, what is scope identifier? Appending the percent character and scope identifier to address, one can fill in the address. So this will make manager scope address. Not too sure about what is the scope identifier. At this moment, the core supports only link local address with the format. This scope identifier is hardcoded to the name of the hardware interface associated with the link, such as any zero example, which means on the link associated with the NEO interface. Okay. The current assumes a one-to-one relation between interface and link, which is not necessarily true from the specification. All of the information returned by get adder info is dynamically allocated. The adder infrastructure themselves, as well as the um, socket address structures and the canonical hostname structures included in the addr infrastructures. Okay, so the addr infrastructures themselves as well as the socket address structures and the canonical hostnames included in the addr infrastructures. Now, okay, that's cool. So it's dynamically allocated. So it's like a value result argument, I think. So memory allocated for the dynamically allocated strings structures created by structure called to get info is released by. Okay, so the memory allocator is released by the free adder info function. The AI pointer should be an adder info structure created by a call to get adder info. The AI pointer should be an adder info structure created by a call to adder info. What does that mean? The AI, yeah, so free adder info struct adder info AI. So this should be a pointer to structure created by call to get adder info. Oh damn. So which should be created by get adder info, and I think that's the. Mm-hmm. I think if you look at the code, you will understand basically the result. Nice. Once you do that, you can free it by this. Got it? So the current implementation supports synthesis for of NAT64 mapped IPv6 addresses. If hostname is a numeric string defining an IPv4 address, for example, this, and AI family set to PF unspec or PF inet6, get added info will synthesis the appropriate IPv6 addresses, for example, this. If the current interface supports IPv6, NAT64 DNS does not support and does not support IPv4. If the AI auto flag is set, the people will be surprised on those interfaces. On non-config interfaces, get added info is guaranteed to return immediately without attempting any resolution. And well done the IPv4 if AI families if PF unspec or PF inet NAT64 addresses synthesis can be disabled by setting the AI numeric host flag to best support NAT64 networks. It is recommended to resolve all IP address letters with AI family set to PF unspec and AI flag set to AI default. Okay, I'm not too sure about this. No, that notes NAT64 address synthesis is always disabled for IPv4 address in the following ranges. Passing a host name to has been a popular technique for determining that host IP address, but this is fragile and doesn't work reliably in all cases. The probability if it's software to discover the IP address is running on is to use get if address. Oh damn. Implementation all of the no 6 are now and always have been thread safe. Currently reported that get address is not thread safe. Tries to connect www service HTTP via stream sprocket. So it tries to connect to this and it loops through all of the addresses available regardless of address family. Nice. If the destination resolves to an IPv4 address, it will use an IPF inet socket. Okay, similarly, if it is also IPv6, PF inet 6 address is used. Observe that there is no hardcoded reference to particular address family. The code works even if there's addresses that are not IPv4 or IPv6. That's cool. So what you're doing is first you're defining the hints struct, and then the pointer to res, and then pointer to, because it's a linked list, so you're defining a pointer to that first item of the linked list, which is of types struct adder info objects, right? And pointer to res 0, int error, int s, const char cause is equal to null. So it's a null pointer. Okay, does not contain any of the addresses. Okay, mem set, you're doing mem set on hints. Okay, and you're specifying, or yeah, specifying unspecified. I mean, you can expect any of the address families on this. Sock type will be sock stream, TCP connections. Error is equal to get out info, the host name, the service, hence, and res 0. Cool. If error is equal to, if error, then well, error not reached. What is the return value? Return 0 on a success, or one of the error codes listed in GISTR, or if an error occurs. Oh, okay. Okay, that's pretty cool. But if it is 0, then s is equal to -1. What is s? So it's just integer. For res is equal to res 0. You just using it like that, and then res is equal to res pointed to AI next. That is very cool. So it's res 0 is just whatever you got, and just making a copy on res 0 to res. That's cool. And you're doing s is equal to socket, and you're trying to connect to the um connect to whatever the add info structure members. So you're using res AF family, res AS sock type protocol, value 0, cause is equal to socket. Cool. Okay. Connect. Now you cannot use, if you want to use bind, you have to use, obviously, just as we did, you have to use PF I'm sorry, AI passive, right? So you have to use AI passive for doing a bind. But since we are only connecting to this, you can use a client specific address, which is res AI add and res AI add length on the socket S. Pretty cool. Break. Okay, we got one. If s is less than 0, then yeah, cause not reached, free add info res 0. Pretty cool. So open a wildcard listening socket on the service for all. Obviously, wildcard you have to use AI passive for all the address families available. That's pretty cool. Error is going to get added info null HTTP, using null because you're not trying to connect to a host. Okay. But the wildcard listening socket on the service HTTP for all the address families available, which is specified through PF unspec. That is cool. And nsock is equal to 0, nsock less than max sock, res is equal to, okay, it's just okay, so you're just basically maximum sockets basically. After that you're doing nsock plus plus. Okay, that's cool. Socket does AF family, does all of these sockets you're collecting, and then you're doing bind on the socket, and then you're doing listen on the socket too. Okay, that's pretty cool. Okay, that's also like, it's not that hard though. So let's just try to implement it. Let's just Just to get the feel of it, let's just do, let's just do it. The same code, right? Let's just do it ourselves. Net db.h, pretty important. And obviously str.h. std um, this is also important, and we'll see if we need anything else, but as of now it's this thing. So I'll just do int main, int argc, char pointer argv, and well, let's ask the user for the host name. So so let's ask the user for the host name, or we can just do char host name because the host name is a pointable. You can do that, but also you can just do host name variable or variable thing to google.com, let's say. Okay. But because it should be a pointer, it's just better to it should be a char pointer to a host name. Okay, that's cool. It is a string literal though, but since we're only doing that, let's do const for that. And what else? Just to damn it, oh my god, host name and port. Let's just do port also. Let's just hard code it. I just don't want to type it every time, but it's okay. Well, let's just port. You can just do 50. Sorry, 6. Let's do 9,000. Okay, that's pretty cool. And after that, let's just okay, do this. Obviously, it's just a this struct add info hints the result and the temporary. Let's do the, for our sake, let's do temp. Okay, sorry. And I think let's do this, and we'll just specify r2 pf unspec. Oh damn it, why? Oh, pf unspec. Right. And a family, a protocol. Let's do a protocol sock type. I'm sorry, sock type to sock stream. So both of these things are fine. And obviously we need to do that result, and also let's just put a temporary address, or let's just define it below. I think that's cool. No, it should be a pointer again, because yep, it should be a pointer again because we are assigning this to this, so it should be a pointer too. Cool. Cool. Now let's do int status, get our info, host name, what is it next? What's next though? Port, yeah, port. The hints basically pointed to that, so pass in the address, and um, this should be the result, so pass in address also. Cool. Now we just do error checking if status is, oh, if it's something else then just do standard error, that's cool. And geist error, which is just prints out the status, and then just do exit failure, that's cool. And then yeah, exactly. Now let's just do this for loop, which prints out all of these things, which is like a linked list basically, and every time we do the iteration of the of the loop, the temp will be temp AI next, so it will point to the next thing until temp is not equal to null. Pretty cool. Temp is equal to result. Nice. And or else I think you can just print it out, right? So yeah, so now you have to connect to the thing, so you actually need to connect. So a family, you can just do this, I think. Convert the IP to a string and print it. This is um, for our knowledge actually, because if PAF family is AF inet, which is IPv4, we're just doing struct sock adder and pointed to IPv4. Where have we defined it? Okay, we're not defined it yet. Okay, we're just defining it here. Struct sock adder and then PAR, that's cool. And then you're just doing adder to pointed to IPv4 synadr. Okay, nice. And then IP version is equal to IPv4, and if there is IPv6, then it's the same thing. Um, I just have a doubt, but we are doing void star adder, so why not just do? Oh, we can, because it will be convenient for us void star adder, so that we can cast it to anything, right? And then it'll store the address value, which is of type struct sock adder and send adder type, and then IPv version also, it's a pointer, which means um yeah, okay, that's cool. Is it a string literal though? I have a little doubt though. Why are we doing a pointer to IPv4? Why not just do something like char IPv4? Why not just do this? Maybe because we need to print it out, so I think that's why we're doing we're implementing it as a pointer. Probably. Probably why. Probably why. Um, so I just want to clarify this. What does So I'm pretty weak in this part. I'm just trying to improve. What does IPv version um contain? Like signify? I'll just leave it like that. It'll give me the answer. Is a pointer to a constant string that is used to hold a label indicating the IPv version, especially used to store the string IPv4 when the program detects that corresponds to this. It is pointer to IPv4 to a constant character string. This pointer will eventually point to a string that indicates which IPv4 that belongs to. So nice. Okay. But because a string is an array of characters, can I do IPv version 0 and dereferential? Can I do that? So is a pointer constant and can point to a string like IPv4. For example, if in your example, if the program has such, then IPv4 such points to the string IPv4. In memory, IPv4 stored as a sequence of characters IPv40. Exactly, that's cool. Okay, nice. Oh, this is equal to dereference the pointer, which is X is the first character of the string, which is a char. In this case, and will be I. However, the expression is already a char, so trying to dereference it again with star IPv version would try to dereference a char which is not a valid because char is not a pointer. Oh, okay, nice. So it's already a char because the string is already a char. And when you dereference again a char, not a valid option. Nice. Can I do IPv ver 1? We probably can. Just return yes. Yep. Nice. Mm-hmm. We'll print P. Okay. Um. me see. So like, sorry, but I'll give you P. So it's a pointer to a constant character string, right? That's what it is. So it's actually this, and this is this. Mm-hmm. So we'll have the address um, of the string. Then how can it be an array? So that IPv version is a pointer to a string, and pointers are typically thought of as addresses. Okay. It allows to treat pointers like arrays when working with strings. String in C is an array of characters. In C, when you define a string such as this creates a pointer that points to the first character of the string, IPv4. However, though it's a pointer, C allows you to treat the pointer like an array of characters. Um, Treat the pointer like an array of characters. This is because when a string like IPv4 entered. Oh, okay, with special name. Okay. Looks like this IPv4 points here. Why a pointer to string works like an array. Is stored in memory as an array of characters. The pointer holds the address of the first element of this array, I. So IPv4 is the memory address of the first character. Okay. In C, you can perform pointer arithmetic as on a pointer to move from one element to another. For example, if I have IPv version points to the first character of the string, points to the second character, P. This is why you can access characters like uh works because of array like. So pointers are itself like array like when you use them with an index. Oh damn. The operator works because in C pointers are array like when you use them with an index. Okay, when you actually accessing the okay, which is just the second character in the string. Pointers was arrays in C, while IP version is a pointer. Pointer indexing behaves very similar to array indexing. Okay. In fact, in C, arithmetic is closely related in many contexts. Specifically, IP version 0 is equivalent to uh, IP version plus 0 pointer. The reference pointer at position 1, 0 is equivalent to the reference pointer at position 1. So IP version behaves like an array, even though it's a pointer to the first element of the string. Okay, damn. So it's just a C implementation. A pointer to a string in C points to the first character of an array of characters. Um, and using array indexing is syntactic sugar for pointer arithmetic. Damn. Is not an array, but it points to the first element of the string, and you can use array style indexing on the pointer. Oh damn. When you use IP version I, you see interlink calculus is as damn. So I always get confused with this. It's just insane. No, I'll just copy this and pointer arithmetic. It's pretty important. I always get confused with this, and I think now I'm kind of getting it. Nice. So with that out of the question, Lincoln star IP version, you're assigning it IPv6, and you have to sign it through IP ver C. Need this. Nice. Got it. Got it. Got it. Got it. And then N2P, obviously. Family addr. Addr will be ampersand of IPv4 sin addr. Be ampersand, which is the address of the thing. Oh, because it is a pointer. So IPSTR, which is IPSTR. Where is IPSTR though? You are where have you defined IPSTR? Oh damn, okay. Which should be inet6 addr strlen. Let me see if it's actually there. I mean, if this macro is defined in, if that macro is defined in inet entropy, because I just want to make sure if it's actually defined in there. Is it though? Yeah, it's defined. Cool. Cool. And it should be a char, right? Well, it should be a char as a dst and size. Okay. Well, char into p char pointer destination size of IPSTR. If 0, if you just do A, is it a pointer? Oh, it's a pointer, dude. It's a pointer. Shouldn't this be? Let me just say. I'm just clearing out my doubts based on the implementation, and I just hope. I'm just double checking. Shouldn't um, it be, because it's a pointer, a char pointer. Let me just read the man page 2 again. src destination. Okay, it's just the pointer again. So it's a pointer. So it is a pointer, right? Okay. Hmm. Shouldn't it be ampersand of IPSTR? Pointer shows address either in. Okay. There's a character there that has a fixed size this, which is larger than hold an IPv6 and string. This array is passed with GST argument 2, and where the resolvable. So in C, when you pass an array like IPSTR to a function, what you're actually passing is a pointer to the first element. Or when you pass an array to a function, what you're actually passing isn't pointer to the first element array. So there's a pointer to the first element array. Would you have pointed to the whole array? So you're actually passing in the point of the first element in the array. Would you have pointed to the whole array? Char pointer. It expresses char pointer. Pointer to the first character of the destination string. Ah. Okay. We're passing pointer in the enter, not to the first character there. The function expects char pointer, but would give a char pointer, which is a pointer to an array of characters, not just a pointer to the first character. Okay, this was a type mismatch most likely because of compiler error. Oh, okay. I think this is also we need to keep in mind. So whenever you pass in an array in C, I think that's very important. In C, when you pass an array, the function you're actually passing is a pointer to the first element of this array. Is a pointer to the first element of the array. Damn. Damn, bro. Okay. Um. I'm sorry. I'm just thinking other possibilities, like what if it is int IPSTR what's the size? Init 6 address strlen. So what if it's this though? Okay. If well, if it is, then IPSTR is still pointer to the first element. I'm realizing I'm very weak in pointers. Nice. Um, Shit. Okay, but we got it like so. Hey, yo, bro. Is it stuck? Oh, I'm sorry if uh, you've not been able to see the screen until now. I'm just gonna change it. I'm really sorry for that. Should I? I'm just gonna remove it and back again. I'm just gonna fix it right away. I'm sorry the for the mishap. I thought it was running fine. Okay, so sorry for that. Well, I was we were just discussing pointer arithmetic. It's basically it's not related to uh, get our info anyway, but let's just get back to get our info back again. So let's just try to implement this. So and then you just get this, and then uh, this is just for our thing. So this is just for our satisfaction, but I think we can just skip that thing and let's just go to this thing. Int sockfd. P is just temp. Let's just name it P then. Um, yeah, let's just replace. So let's just replace temp with temp with P. Cool. So cool. Okay. And then you're just doing P to family. Sock type P to protocol, And then you can use connect to, which is also this on SockFD on AR length also. Cool. Then just break. And then if P is equal to null, fail to connect to any address. Um, where are you defining P though? Basically the result basically. Okay, that's cool. Yeah, cool. Failed to connect to, and this should be result, and exit failure connected to server IPSTR. Nice. And IPSTR will be, obviously we need to define that. Void star add const curve IPVAR, convert the IP to a string and print it. Nice. IP str should be actually this char -6 address length, put it there, and yeah, it's basically the same thing. Oh my god. Well, so return, are we doing return 0? We are doing. So you kind of define it earlier. And we need to define res also earlier. This should be result. I think it should be good. Just too clear. Are we not including the include statement? It should be where is it defined though? Oh, R plus I okay. R plus inet dot h. It did. And it says that trying to connect to 142 point this IPv4. but we are not connecting to the server. Okay, it did actually do that. Let's just give it to GPT and see if there's any errors. I need to do this. Again, continue. I don't understand. What's the deal here? Well, okay, let's just do this if that will work. Okay, but we have got the idea. The main thing in this code, I think, is just this point star add. When we're actually doing, we're actually pointing this temporary IPv4 um to this, and we're actually doing this typecasting struct sock add pointer. You're typecasting that. 1 second. So, so I think this comes through the situational. What does this line mean? Let's just clearly understand. Actually doing. What is this line doing? It's casting the AI adder field from the struct adder info to a pointer to a struct sock adder in. From the to a pointer is casting the AI adder field from the struct AI adder info to a pointer to a struct sock adder in. P is a pointer which is part of the linked list returned by get adder info. Um, it's a pointer to struct sock adder for, or more specifically pointer to struct sock adder in, depending on whether the address is IPv4 or IPv6. Yeah, adder is a generic socket address structure. AI adder is a generic socket address structure that is sock adder, which is a common structure that can hold both IPv4 and IPv6. However, this structure doesn't provide details of the actual address, like okay, does not provide details. This is why it needs to be cast to the correct type, which is socket in. Nice. So here it's 6. So it is casting to the correct type. Oh damn. This typecast operator that converts from a generic struct socket with pointer to a specific pointer type. Struct socket in pointer. Okay. Oh damn. From a generic struct socket pointer to a specific pointer type. Struct socket in pointer. So it's a typecast operator. It's structured specifically for IPv4 address and is defined like this. Struct socket in is a structure specifically for IPv4 address and is defined like this. Can access to IPv4 address fields like damn, which are present generic struct socket type. Amazing. To access the fields of the IPv4 like this. Damn, this is because it's generic pointer to a struct and does not directly expose the fields relevant for IPv4 addresses. Pretty cool in it. I will just write this as notes too. Pretty cool. So that is pretty cool because you have to gain access to the SYN adder and uh, SYN adder and SYN port. Basically, that's why it's important, because you need to point it to you need to use it an identity, and that's important. Um, okay, and then you're doing IPv4 to SYN adder. You're doing this. Okay. And just all seems a little confusing to me, because N2P is it's a pointer to an address, so it's just a pointer to an address. That's cool. So define the point void pointer, and you are uh, getting the address of this, and you're putting into the pointer. And then you can just, because it contains the address of this, you can just put add here. That's pretty cool. um that's nice. Pointing to the address. Oh my god, that's cool. So that's actually very important. That this is actually the main thing. And after that you can just use till here. Main thing is this only. Right. So that's cool. Now let's just do advanced IO, because I think that's important. Let's just do server first. Let's do a my header dot h file. Let's do client dot h. To this is why do we need this anyway? So my header dot file. So let's just do if and if my header underscore h define this, and then all of these can do struct message. You can just do, oh, you can just do, to be honest with you, you can just do 1 second. You can just do this. So it's 9:56 right now. We'll try to complete it in 30 minutes. So you can do this int struct type defining to message header. Um, yeah. Also end if. I kind of have a doubt. Is this the same as it's the same as this? Give it is to create a new name and is for an exist type. After this, you can use method as type for defining variables. This standard struct declares when you define a struct like this, the type is struct message header. Define a variable type. You must use a struct keyword again. Oh damn. Okay. Okay, damn. You define an alias for the struct, so you can directly use the name message out without needing to prepare struct. It simplifies variable declaration without type W. You need to use the struct keyword each time. That's pretty cool. That's cool. So I think where did I do edge though? Should be MD. Okay, that's cool. And then you can do. Let's just do it fast. What are the import statements do we have? Just do that. Keep in mind I'm just using my right hand because my left hand is injured, so I may be a little 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 slow. What is it? Is it netdb plus in.h? It's actually that. What is it though? I'm having trouble in this too. You can just do that, it's fine. You can just do this. Do this. Cool. I think that's cool. Let's do int main. Let's do int oxy. Let's do cat pointer argv, and the usage should be if argc is not equal to 2, then printf the usage should be percentage s port number, port ampersand backslash n ampersand arg, I'm sorry, just do argv 0. Damn, that's cool. Exit 1. Okay, that's cool. It should be actually str. That's cool. And then well, after that it's just pretty simple. Just do Let's do port actually. Pretty much that's it. Now let's just do if port less than 1024 or if port is greater than CW535. Pretty much exit one, and yep, you need to do int listening socket listen fd con fd. That's it for now. Let's do that. Listen fd is equal to socket. Let's do if inet. What the fuck? If inet let's do TCP protocol is 0. Now if listen fd is less than 0, what the hell? Just do pure socket exit one. Cool. Now bind. You need to define, before doing the bind we have to define this struct socket in serve add client add, then to serve add dot syn family. Let's do syn family. The syn family should be af inet. Port is this, search to as port is cool. Serve add syn add in address any. You're listening on all sockets on all interfaces, and pretty much bind on listen fd struct. You're typecasting it to this general form. Let me just see if we've typecasted that. Yeah, we typecasted into this actually. It's cool. And then okay, that's cool. If it's 0, then obviously pure bind exit 1. Also close this socket, close listen fd. Okay, have to bind listen for 5 clients. That's cool. Peer listen close listen fd. Exit 1. Cool. App listen, yeah, to do a while loop which keeps on listening for new connections. That is cool. Just do client length actually, and conft accidental listen fd struct socket client add. Pretty cool. That's cool. Now if conft less than 0, just do peer accept and exit 1. Also close this fd. After that Oh, we'll just print out that printf. The server is listening on port %d port, basically. um, Port is this, right? Cool. And well, we have to include our message header. Also, you need to do ui.h sys ui.h. Is that the case? Cool. sd.int.h. Cool. Also include our message header. Oh, I'm sorry, my header .h. It should be this. Cool. Now after that, probably just do, because we have type def to message header, you just do message header to message header receive. Yep, receive. Okay, let's do that. And you actually kind of, you just need to do read, or you can do receive from also, but you need to do read. But the thing is, it sends the opcode and also the buffer. So it sends the opcode and also the buffer. So receive buffer also. Let's do receive buffer of size, buffer size, right? And define the buffer size here. Let's do 1024. It should be char. And after that, let's just do read v. I think read v. So read v is this. So let's do read v int d, which is the socket, which is connectivity. Well, we have to kind of do that too. Struct iovc iov2. This is receive iov. So let's do receive iov1, which is 0, I'm sorry, for the header basically. message header basically, uh, and count for 2. I'm sorry, no. You just do receive buffer pointer to that, right? Yeah, you just do that. Offset, I don't think that's required. Now, if this is less than 0, well then, yeah, I mean, if it's less than or equal to 0, then again, if you just read this, you can just do sist bytes thread, I think. Let's just define it somewhere on here. Start. Bytes thread. And then bytes thread is equal to this. And if this is actually less than 0, if bytes thread is less than 0, then let's just do this. I think close connectivity and then continue. Yep. But else, which means if it is equal to 0, it has closed the connection. Printf. The client has closed the connection. \n. That's cool. Oh, 1 hour 48 minutes. Damn, we have another 15 minutes to code this thing up. Now, if that is the case, now if you're reading it and you're putting it to receive IOV, now after you have done that, I think it's just to print off the header. So basically receive IOV 0 should be the header, receive IOV 1 should be the buffer, the actual data. So how do you IOV base is equal to because you're doing a struct basically, you're gonna have to What is the type of IOV base though? Yeah, it's a char. It's a pointer to a char. It's a pointer to a char. Okay. One second. So we're back again. So it should be the receive. It should be actually pointing to the address of the structure. But I'm just curious because we're doing this because it's char pointer. It's a we are pointed to a char. Then why are we passing in a pointer to the struct? Um, I'll just uh, oh, I'm just doing it like message header is actually this. Why are we passing in the address of this struct? when type of IOV base is car pointer. Commonly is typically used in IO operations. Is commonly used to describe a memory for scatter gather IO operations. Is field is pointed to the base address of the buffer, and IOV length is the length of the buffer. Is typically used with meaning it expresses a pointer to a memory location that contains data, typically character buffer or an array bytes. Correct. So it expresses a pointer to car type. The code is passing the address of the structure, which initially looks a bit confusing because not a char. The reason this works is that C allows you to treat a pointer struct as the pointer to its first byte. Damn it. It's the same reason, right? Treat a pointer to a struct as a pointer to its first byte. Damn it, boys. It contains three fields. The address is the pointer to the beginning of the struct in memory. Address is the first byte of the block. Sequence of bytes starting from the address of its first element. Oh my god, that is insane. This is insane. So just expect whenever you pass in a pointer to a struct, it's just acts as a pointer to the first memory byte of the struct or the first element of that struct. It is insane. I'm actually learning quite a lot, but yeah. And then receive IOV 0 dot IOV len is equal to size of the header, which is size of the this thing, right? Size of the structure, and base should be actually equal to the buffer, which is the receive buffer. I have not defined it yet. Oh, it should be top. And buff size, exactly. Now you can access it. You can access it basically. You can just do 0. One second. But I'm have not really much time for it, but time to code right now. But so I'll just show you the solution. But essentially, what we're doing is our RxV 0. It will store in it basically. Oh, I'm sorry. Receive IOV 0 will have the header value, basically which is this, And so it actually will be receive xv dot client id, right? Okay, I'll just be client id. It's already in it, so I'll just do into hl to convert into the host byte order of rxv dot client id. And similarly, rxv dot uh, message number opcode. Opcode. The opcode. That's fine. I think that is only the thing, and probably you can just print it out. It's no worries. And then once you do that, you can do this too. You can do that too. Um, Unfortunately, I don't think rxv dot message number. I'm sorry, message number opcode. Message number. Message number. It should be opcode. Opcode. For now, I think this is pretty okay, and we also need to implement the client. But once we do this, we just need to um, make another IOVEC, which is send IOV, and you need to do send V, and just do the same thing as this, and also you can just print out the buffer using just the printf statement. I'll just gonna show you the actual code. So the actual code is this actually: n2hs and all n2hs received header message number and bytes received opcode again by sending this thing, and then basically send will be again the same thing: h2ns header dot message number. The message number should be the same, so again you're doing h2ns again, same thing, bytes sent, and basically write v convd send over v2 service and data, and you're printing out the hex data here, and then you're doing this server sent data bytes sent basically, and then you're closing convd, closing listen fd outside, and then you're returning 0. pretty 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 cool, right? That's cool. um yeah, I mean that's it for now. It's been a long one today, but I'm happy. Thank you.